students. Today we are going to discuss one more important topic in signals and system and jet transform is causality and stability of jet transforms. What is causality and stability? It can be determined, causal and stability can be determined from the poles and zeros pattern and the ROC of the transfer function h of z. Already we know how to find the h of z. H of z is nothing but a jet transform of h of n. From that, from the h of z transfer function, we have the poles zeros pattern and ROC. From that, we are going to calculate the stability and causality. Now first we'll see what is causal. Causal is nothing but its impulse response h of n must be equal to the 0 for n less than 0. That is nothing but h of n is equal to 0 for n is less than 0. Alternatively, if the system is said to be causal, then the ROC of h of z will be outside the outermost pole. That is causality. Same thing for the stability. If the system is stable, then its impulse response h of n must be absolutely summable, or causal system is said to be stable if the poles of h of z lies inside the outer circle of the jet plane. So they has to satisfy these two. So we can conclude this one. If the system is said to be both causal and stable, then the ROC be the unit circle and must be the outside of the outermost pole. So this causality and stability we can see in detail with example. Consider determine whether the system described below is causal or stable. We are going to find whether the given system is causal and stable. First, consider this system. H of z is equal to 2z plus 1 divided by z square plus z minus 5 by 16. So, in the numerator, I am going to take 2 common. So, we have to write in terms of poles and zeros. So, if you take the 2 common, z plus 1 by 2. In the denominator, we are going to write roots of that one. So, that is z plus 5 by 4, z minus 1 by 4. In this problem, we have 2 poles. The 2 poles are, one is z is equal to minus 5 by 4 and another one is z is equal to 1 by 4. Z is equal to 1 by 4 is nothing but a 0.25 and z is equal to minus 5 by 4 is nothing but a minus 1.25. Now I am going to check first the stability and causality. Here the poles is outside, the one pole is here, one pole is. So if you draw the unit circle will be lies here, negative axis minus 1 and positive axis plus 1. So in this one pole, see in the jet plane we have one pole at minus 1.25, that is outside the unit circle. So hence the system is not causal and stable. If the system should be stable, all the poles should be inside the unit circle. That is the one condition. So the system is not causal and stable. Understood? So because of this one root. Next we will see another example. H of z is equal to 1 plus 2 power z minus 1 plus 14 by 8 z power minus 1 plus 49 by 64 z power minus 2. Find the system is stable and causal. We are going to find whether the given system is stable or and causality. Now consider h of z. Same thing here. I am going to find the poles of the system. So we have to simplify. We know z power minus 1 we can write it as a 1 by z. So 1 plus 2 by z whole divided by 1 plus 14 by 8. Z power minus 1 is 1 by z plus 49 by 64 into 1 by z square. Now if you take the LCM and if you simplify, we'll get it z square plus 2z divided by z square plus 14 by 8z plus 49 by 64. Now in that numerator, I am going to take the z common. If you take the z common, z into z plus 2, and also we are going to find the roots of the denominator, because roots of the denominator always it gives poles of the system. So from the poles only we are going to identify whether the system is stable or causal. Now here we have the two poles at z is equal to minus 7 by 8. Both the poles lies at z is equal to minus 7 by 8. So that is nothing but minus 0.87. If you draw the same z plane. You know, z plane we have the real axis and imaginary axis. If you draw the unit circle, so this all the both we have only two poles in this system. The two poles lying inside, because the unit circle which lies -1 and +1, but our poles are -0.87 and minus point, both are -0.87. Both the poles are lying inside the unit circle. Hence, inside the both the pole, all the poles are lying inside the unit circle, means the system is both stable and causal. Clear? The previous problem, one pole is, or even one pole is lying outside the unit circle also, the system is not causal and stable. So here in the system we have only two poles, both the poles are lying inside the unit circle. So the system is causal and stable. Clear? Now we'll go one more example. A LTI system is given by the function h of z is equal to 3 minus 4 z power minus 1 divided by 1 minus 3.5 z power minus 1 plus 1.5 z power minus 2. Specify the ROC of the h of z and determine h of n for the following condition. First one is, if the system is stable means what is h of n. If the system is causal means what is h of n. We are going to find out. Consider the given system h of z and simplify. How to simplify? If you want to do anything, we have to find, if you want to find h of n, we have to find the denominator roots. In the denominator, we have two roots. One is 1 minus 1 by 2 z power minus 1. Another one is 1 minus 3 z power minus 1. So, you know, we already last class, lecture we discussed so many different types of inverse z transform techniques. We want to find h of n. They gave h of z. So how will get h of n? By applying the inverse z transform. So we have three inverse z transform methods are there. In that, easy method is partial fraction method. So here apply the partial fraction method. So how to apply? Based on the denominator roots. We have two roots. So a divided by first root plus b divided by second root. So you can to get a and b, we can do any method to get a and b. That and all you people already know. So find out a and b and substitute. Our h of z is, a is I got 1 value and b is 2. So 1 by 1 minus 2 into z power minus 1 plus 2 by 1 minus 3 into z power minus 1. Now the poles are, what are the two poles? One is at 1 by 2 and another one is z is equal to 3. What they asked? They asked you to write for a stable condition. They gave, if for the what is the condition for stability? If the system is stable, ROC must be include the unit circle. Must be include the unit circle. So it must be include the unit circle is nothing but our h of n is equal to that should be inside, that should be in between 1 by 2 to 3. So our h of n stable system 1 by 2 whole power n into u of n plus 2 into 3 power n into u of n. So ROC is must be included that unit circle. Okay, it should be less than 3 and greater than 1 by 2. Okay. Greater than 1 by it should be include the unit circle. It should be include the unit circle means in the, this is normal condition. If we are going to write h of n for the stability system, that ROC should be include the unit circle. So if z is equal to 3, if we write that one means, so here we have to take it as this mod of z should be less than 3 for stability system. So our expression is 1 by 2 whole power n into u of n. Here minus 2 into 3 power n into u of minus n minus 1. Clear? This for this stability system. So this 3 should be greater, this 3 should be inside the unit circle. So mod of z should be less than 3, not greater than 3. Okay, less than 3. Then only it will be ROC is including the unit circle. Same thing for the stability to be causal. So ROC be the outside the unit circle. ROC be the outside the unit circle is nothing but we have to consider the mod of z is greater than 3. Then only we can consider. So in that case h of n is 1 by 2 whole power n u of n plus 2 into 3 power n into u of n. Clear the difference between, if the any system is said to be stable, the ROC must be include the unit circle. Must be include the unit circle, not outside. If the system said to be a causal system, ROC should be outside the outermost pole. So in that outermost pole is nothing but a, the outermost is nothing but the bigger one. So this bigger one is nothing but a 3. So ROC should be outermost pole. If the stable system means ROC should be include the unit circle. If it is a causal system means ROC should be outside the outermost pole. Clear? Then next we'll see one more problem. A causal LTI system is described by the differential equation y of n is equal to y of n minus 1 plus y of n minus 2 plus x of n minus 1. Find the system function and plot the poles and zeros. Indicate the ROC. Find unit step response of this system. Find a stable unit sample response that satisfies the differential equation. Okay, these are the 5 steps we are going to find out. So any step, they gave the system in terms of differential equation. Now we are going to convert the differential equation by applying the Z transform. Apply the Z transform to the differential equation. Y of n becomes y of z is equal to y of n minus 1. Z transform is z power minus 1 into y of z plus z power minus 2 into y of z plus z power minus 1 into x of z. Take all the x or y of z terms in the left hand side and x of z in right hand side. Now we'll get it, and after that you take common y of z. So y of z of 1 minus, if you take this one the right hand side, plus becomes minus 1 minus z power minus 1 minus z power minus 2 is equal to, we have only one x of z term, that is z power minus 1 into x of z. We know the transfer function x of z is, h of z is nothing but y of z divided by x of z. So I am going to convert the above equation like this. Y of z divided by x of z is equal to z power minus 1 divided by 1 minus z power minus 1 minus z power minus 2. Clear? Now our x of z is, h of z is equal to, now I want to write the poles and zeros of the system. Right, z power minus 1 is nothing but 1 by z, and this we can write it as a 1 minus 1 by z minus 1 by z square, and convert the h of z in terms of only z square, and find the roots of the denominator to plot the poles and zeros in the z plane. Okay, now poles are z is equal to 1 by 2 and z is equal to 3. Now poles are, now the poles are at z is equal to, poles at z is equal to 1.618 and minus 0.6182. Correct? Now since that is the first one, now what they asked, since the given system is a causal system, what is the condition for the causal system? ROC is, causal system is, ROC is outside the outermost pole. What is the outermost pole? Outermost pole is 1.6. So mod of z should be greater than 1.618. Okay, clear? Now h of z is nothing but, if you want to find out h of n, how to do it? We have to apply the inverse Z transform. So here also we applied the partial fraction method to get it. So we have the two roots in the denominator, a divided by first root and b divided by second root. So we got the two ab values is minus 0.447 plus 0.447. After that we can apply the inverse Z transform to get h of n. H of n is equal to minus 0.447 of minus 0.618 whole power n. For this, a power a is nothing but a minus 0.618 whole power n into u of n, and next one is plus 0.447 is the constant. Here a value is 1.618 whole power n into u of n. For the stable system, the ROC should include the unit circle. Correct? For the stable, this is for the causal system, ROC should be outside the outermost pole. Same thing already I told, for the stable system, ROC should be include the unit circle. Should be include the unit circle is nothing but mod of z. Mod of z is greater than 0. Should be greater than, correct, greater than 0.618, and it should be less than 1.618. So in that case, if it is greater than means it will be as such only. So minus 0.447 minus 0.618 whole power n into u of n. Here mod of z is less than 1.6 is nothing but that u of n becomes minus u of minus n minus 1. So this is for stable system, this is for the causal system. Understood the concept stability and causality? Clear? And next class we'll see some more problems regarding stability and causality. Thank you for